next unit in 5 CST is on circuits and paths. Before we get there, though, we have to talk about the characteristics of a graph. So we're going to talk about graphs, connected graphs, and complete graphs. First, what is a graph? Just to clarify before you even come up with any answer, a function is a type of graph. So you can't say like a line or parabola is a graph. It's a type of graph. This is not a graph. This is a Cartesian plane. The definition of a graph says that a set of elements and the links that exist between these elements are a graph. So graphs can come in many different shapes and forms as long as there's a set of elements and links that exist between these elements. For example, a linear function is a type of graph, a piecewise function is a type of graph, etc. But there's links that exist between the elements of this graph. The graphical representation of a graph is putting the set of elements into a series of lines or curves, usually on a Cartesian plane. Usually on the Cartesian plane we graph things. That's how you've seen it. In a graphical representation, though, note the following. The points, called vertices, correspond to the elements of the set. So you should know this because in a function, a point xy corresponds to the elements of the set xy. The lines in a graph are called edges, and they correspond to the links that exist between those elements, or those points, if you will. The vertices are generally identified, and you've seen this by a lowercase letter, an uppercase letter, a number, or a word. So usually when we see points on a graph, we call them point A, point B, point 1, point 2. And an edge is generally named by combining the letters that identify the endpoints. For example, point A to B creates edge or line AB. You've seen this before several times. In this graph below, note the following. So here's the graph. As you'll see, this is actually a graph. Okay, it doesn't look like your typical graph, but it is a graph with different elements, vertices, and edges. So we'll note the following. First, points A, B, C, D, and E are vertices, and E has a star next to it, so we'll get to it in 1 second. AB, BC, and CD are edges of this graph. Now, point E is a vertex, yes, because it does correspond to some element of the set that the graph is representing, regardless that it's not touching one of the other points or it has a line connecting it. Try this on your own. Here's a graph. What are the vertices of this graph? And what are the edges of this graph? The answer is that points 1, 2, and 3 are vertices, and the edges are 1 to 2 and 1 to 3. We're going to talk about characteristics of a graph. Now, there are 5 of them. This slide has the first 2. The following characteristics can be associated with a graph. The order of a graph corresponds to the number of vertices, and the degree of a vertex corresponds to the number of edges that meet at the vertex. So if we talk about the first one, the order of the graph corresponds to the number of vertices. Here's a graph. It has 3 vertices. Therefore, the order of this graph is 3. The degree of a vertex corresponds to the number of edges that meet at that vertex. In this case, the degree of vertex B would be 2 because two edges meet at that vertex. These are going to be the next 3 graph characteristics of the 5. Number 3, 2 vertices connected by the same edge are adjacent. So here, vertices A and B are adjacent because they are connected by the same edge. Number 4, edges that connect the same vertices are parallel and are generally written using numbers in parentheses. Now this might be gibberish to you, so let me show you. Here is a vertex X and vertex Y, and they are connected by the same kind of line. Now this line is XY, but this line too is also XY. So first of all, these 2 lines are parallel, even though they defeat what it is that you think is parallel in the sense that 2 lines have the same slope. In a graph in our chapter, so edges that connect the same vertices are called parallel. So that's why we number them, because we have 2 XY edges. So we're going to call this one x1y, and we're going to call this one x2y, and we'll say that they are parallel to each other. And finally, an edge that connects a vertex to itself is called a loop. Over here, we have a loop. You've seen loops before. Edge j to j, here is a loop. Identify some graph characteristics. Here's a graph here. Find the following, if any. Can you find the order of the graph, the degree of the vertices, the adjacent vertices, and parallel edges or loops if there are any? So I feel like the order of this graph is 5 because there are 1, 2, 3, 4, 5 vertices. There are vertices that have degrees of more than 1, which we'll name. K is 2, M is 3, but also, I forgot to mention, but L also has 3, P has 2. Vertices M and P are adjacent, so is L and P, but so are L and K, but I just didn't put them, but you'll get the idea. For parallel edges, we have 2 here. We have that K and L are parallel, but in this case it would be K1L and K2L are parallel because they share the same edges. And finally, edge MM here is a loop because it's a vertex that connects to itself. The second thing after characteristics that we're going to learn is called a connected graph. A graph is considered connective if any vertex is linked, directly or not, to all other vertices of the graph. So here are 2 graphs, and I want you to guess or to tell me which one is connected and which one is disconnected. And remember, connected if all vertices are linked, basically. This one is a connected graph. This one is a disconnected graph. The third kind of graph is a complete graph. A graph is considered to be complete if each vertex is directly linked to every other vertex. So here are 2 graphs. Now remember, for it to be complete, each vertex needs to be linked directly to every single other vertex. Can you guess which one is complete and which one is not? The first one is a complete graph because its vertex is directly linked to every other vertex. And number 2 would be an incomplete graph. And that completes our first chapter of this unit on graphs and paths. Characteristics of graphs is what we learned, as well as complete and connected. Next, we're going to go into more depth about these graphs, and we're going to study paths and circuits.